wherever you are. I'm very happy. Today we are going to tackle another uh, chapter. It's about method of exactness for some solutions which are not exact. So by the end of our today's lesson, you will be able to identify the part M. You will also be able to identify the part we call N. We should be able to identify the U and the so for U, and if the equation is not exact, to know how to provide the integrating factor for the same, and how to know that this one was not exact. Meanwhile, just press the subscribe button, like, and comment after the video, and tell me maybe what have you learned and maybe what have you seen, as we are going to come up with other things. So by the end of today, we shall be covering how to come up with the integration factor and we are going to look at method of exactness. And remember, as we had talked earlier, we said that not all solutions that you are given are exact. Like for example, we are given a simple question here, then we are told you to solve using method of exactness. And what you normally have to consider is first to check whether the equation is exact, and if it's not exact, then what are you going to do with it? Are you going to leave it at that point, or you are going to continue with it? So once again, you first have to identify the part that is the M, and it is this part will be the X, and the other part with the Y will become your N. So once again, what you normally do is first to differentiate your M with respect to Y, and check whether it is equal to if you differentiate N with respect to X. So what is the derivative of this this part M with respect to Y? The part with so it is dm dy. So the part will be x. If you differentiate x with respect to y, you will always get a 0. Remember, it will give like a constant. Then 6y squared, if you differentiate, you are going to get it is 12y. Then you come on the other side with n, then you differentiate n with respect to x, and check what you will get. If you are differentiating 4xy with respect to x, you are going to get it is 4y. So at this point, you are able to know that this one and this one is not equal, hence it is not exact. And if it's not exact, what do you normally do? First, you have to find the integrating factor that you will use to multiply with the original equation that you were given to solve, and check whether you get now exact. So once again, the formula to get the integrating factor is the exponential. Then you take your first the derivative of m with respect to y, you subtract derivative of n with respect to x, then you divide it by x, the n itself here. So what are you going to get? If this gives us a function which is either x alone or y alone, then you are going to use it. But if you get the mix up of both x and y, then you just leave it out. So once again, you have this this exponential, then our dm dy was 12y minus the other one gave us 4y. Then you are dividing with n, and our n is 4xy. So once again, what do you get? You get it is exponential 12 minus 4, you are getting it is 8y, then it is over 4xy. Then when it is like this, your y and y cancels off, and you are getting it is you are this one. Let's simplify. You are getting this 2, since this this cancels, you get 2 over x dx. Since this one is like a constant, when you move out the 2 and you remain with x, which is 1 over x, then dx. When you integrate 1 over x, what do you normally get? You'll get ln x, so you'll get it is exponent of 2 ln x. When it is like this, you can just take 2 to the other side and it will be x ln x, then this one will be squared now. And there is a law that you have to know that if you take an exponent, then power ln, you get 1. So what you get here is just the 2, is just the x squared, and our x squared is our integrating factor. So if you have the integrating factor now, what you normally do, you multiply through here. So it is x squared multiplied by this, it is 8x plus 6y squared, and this is dx, plus the other one was 4xy dy. Then check whether now this one you are multiplying through by our integration factor, check whether you get 0. So once again, if you multiply this, you are getting it is 8x cubed plus 6x squared y squared, and all this is our dx, plus if you multiply this with this, you are getting it is 4x cubed and y. When it's like this, then in dy. So once again, check whether you are getting it equal to 0. So this part will be our m, the other part will be our n. So what you normally do, you just come here and just confirm whether now it has become exact. Since now we have introduced our integrating factor, to check whether after introducing it, it is correct, if it is now exact. So if you differentiate our m with respect to y, what do you get? This one will act like a constant, so it is 0. Then this one, if you differentiate with respect to y, you are getting it is 12x squared y. Let's check on the other side, n with respect to x. What do you get? It is 4x cubed power this with respect to x, so it will be also 12x squared y. Hence, we are able to see that it has now become exact. So, it means that our integration factor here was correct. So, once again, let's look for u. And we normally say du dx should give us m, and du dn should also give us now n. So, once again, let's take our du dx, and this is now our m. It is 8x when it is cubed plus 6x squared y squared. Then what do we do normally do? Remember, this is now our m. So let's multiply through by dx. Let's multiply through by dx. So you are getting it is du. It is equal to what? 8x cubed plus 6x squared y squared, then dx. So let's integrate in both sides to check whether you are getting our u in terms of x and y. So if we integrate this function, if you integrate this function with respect to x, it is 8 x power 4 over 4, so it will be 2x power 4 plus, if you integrate this with respect to x, you get it is 6x cubed y squared and over 3. So 3 cancels with the 6 to get it is 2x cubed y squared. Then whenever you integrate anything, you must get a constant. So the constant that you are getting will be in terms of y. Will be in terms of y. So once again, you come here and see that now you have your u, but you say if you differentiate u with respect to if you differentiate du dx, you should get n. So let's differentiate this and check whether we are getting. So du dy, it should give us n. So let's differentiate this with respect to y. This one is just x in terms of x. So if you differentiate in terms of y, it is 0. And if you differentiate this with respect to y, you are getting it is 4x cubed y plus f prime of y. So once again, this one, as we said earlier, should be equal to our n. Then what is our n from here? Let's equate it with 4x cubed and y, and it's like that. So you are able to see that this cancels with this if you take this to the other side. So you are getting your f prime of y is equivalent to 0. So even if you integrate 0 with respect to y, you are getting that your f of y is still 0. So once again, our final answer, it is this one, the one we got as u. So it is 2x power 4 is 2x power 4 plus 2x cubed y squared. 2x cubed y squared. So this is our final answer. So once again, you should be very keen to find for your integrating factor. This will act as our engine when we are looking for this answer. If you don't get the correct integrating factor, then everything else will just go in a mess. So thank you.